Hello, my name is Josh and I'm here for the 1 p.m. science demo here at Arizona Science Center, or as you can see, in my living room as we all continue to practice safe social distancing to help keep us all safe and help flatten the curve. So thank you again for joining today. My name is Josh, and for today's science demo, I'm going to be showing you how you can grow copper crystals using the power of chemistry. If you like this demonstration or you missed part of this demonstration, you can view all of our content at azscience.org. Or you can also check out our Facebook for more posts like this. You can check out our Instagram or our YouTube channel, which has all of our Facebook Live demos as well as several other demos. So, with that being said, let's get started. So, we are going to be growing our copper crystals using chemistry. When we are talking about chemistry as a science, we're really talking about changes in the states of matter or working with atoms, things like that. So, an atom is just the really basic founding block of basically everything in the universe. An element is where we start to talk about things on the periodic table. So for example, I may have one atom of hydrogen, right? And then if I add a second atom, words are hard, a second atom of hydrogen, I now have two atoms of the same element. That's called a molecule. And if I have my two hydrogen atoms and I add in an atom of oxygen, that becomes H2O, also known as water, but is now a compound because we have multiple elements in the same molecule. So we're going to be practicing that we're going to be using that as we grow our crystals. And the first thing, I'm going to put my PPE on to make sure that I'm staying safe. The first thing that we're going to do is I'm going to take my compound, which looks very bright blue, is very pretty. This is copper sulfate. So this is copper, sulfur, and oxygen atoms. And I'm going to take 5 grams of copper sulfate. And because I don't trust my motor skills after I've had this much caffeine, because working from home means you are left alone with your coffee pot all day. So I'm going to take 5 grams of copper sulfate, and I'm going to pour that in here, and make sure that it all goes down to the bottom. Put the funnel to the side. And I'm going to use a pipette just for a little bit of precision. Inside this cup is just water. So I'm going to take my pipette filled with water, and I want to make sure that I have just enough water to cover all of my copper sulfate. So it's filling up the bottom, and I want to make sure that I have just a thin layer of water on top, like that. And next, this is going to be just a round of cotton. So we're actually going to use this as a solid barrier. You're thinking cotton, that's interesting that we're calling it solid. Well, it is, because a solid holds its shape, but we're also using cotton because, as those of you following along probably guessed, it's going to absorb the water, and that's going to help us grow our crystals. So I'm going to take the flat end of my skewer and, to the best of my ability, push this cotton round down, and I'm going to push it as much as I can until I get it to cover my copper sulfate, just like that. So I now have a bottom layer, which is our copper sulfate and water on the bottom, and then the solid barrier, which you can see it's already starting to absorb the water of the cotton. And then for the next one, I'm going to use something very complicated and mysterious called sodium chloride, right? This compound, sodium chloride, is also, if you know what it is, let us know in the comments below, or I'm going to tell you. Sodium chloride is just another name for common table salt, the kind that you put on your dinner. So again, we have 5 grams of sodium chloride, and that is why we use the funnel. And I'm going to do my slightly less than 5 grams of sodium chloride on top, and again, repeat the process of putting just a thin layer of water, just enough to fully cover the sodium chloride. And it looks like I need just a little bit more. Should be good. And then, as you guessed, to get our second layer completely covered with our solid barrier of cotton, going to put it on the top and poke it all the way down. Whoa. As far as I can with my finger. Then using the skewer. Whoa. get that to cover our salt and water layer. And then I'm going to take a nail, and this is an iron nail, which is important, we'll get to later. And I'm going to drop it in just like that, and then check to make sure that it has gone through, poked in a little bit further, gone through my first layer of cotton and into the white part, right? So you use the black Sharpie line, that's the bottom of the top layer of cotton. So I can see that it's in the salt and water mixture, but it is not directly touching the copper crystals, or excuse me, the copper sulfate at the very bottom. And that's important, so I'm gonna do the same thing again with this nail. And make sure that, poke it down a little bit. Make sure that once again, this second nail is going to go through the first layer of cotton, and I cut it pretty close, but we should still be okay, to make sure that it goes into the white part but stays away from the blue crystals. That's gonna be really important. So what is really happening in this is we talked about our compounds earlier. So we have copper sulfate in the bottom layer, and copper is a pretty stable, it really just wants to be left alone, and that's how we're gonna get the copper crystals at the end, where sulfate is super, super, super needy, also known as very electronegative. And then as we go through the first cotton layer, and we get into sodium chloride and chloride both kind of break up and split up, and the sodium is much more reactive than copper. So the sulfate gets to the second layer and sees the sodium and is like, hey, you're mine now, we're gonna bond together. And that leaves the chlorine and the copper to eventually go to the other side and start to form a compound over there. And then once this nail gets introduced, the nail, which is iron, the iron in the nail is much more stable and much more attractive to chlorine. So the chlorine is like, hey, we're gonna bond to all the iron, and that essentially leaves the copper all alone, which is really all it ever wanted in the first place. So what does that look like, you asked? So glad you asked, internet. I'll show you, because I made some examples over the weekend. And if you want to zoom in, I'm going to hold both of these up, and you can see the different layers. So in both of these, right, similarities and difference. Believe it or not, I made these at the same time, but one of these I didn't put quite enough water, and one of them I moved the nails around too much, which is why you do multiple trials. But if you can look on both, you can see the blue. That was what the copper sulfate was initially. And then you see some murky stuff as you hit the first cotton barrier. And then you can still see in both, there is a white layer. That was our salt, or our sodium chloride. And then all of this kind of gross looking orange stuff. Before I tell you, using the elements we have, what do you think the gross looking orange stuff is? Or maybe you like the color, right? Maybe I shouldn't call it gross. Cool. If you guessed rust from the nail, you are absolutely correct, right? Rust, the chemical structure for rust is FeO. That's not the exact chemical structure, but it involves iron and oxygen. And that is where you get some of the rust showing as the oxygen forms around the iron. But the copper crystals, and what we're here to show you, actually form wherever the copper gets left alone. So if you see kind of that beautiful, brilliant copper, this is something that has been growing for 3 days, and this reaction will probably continue to occur for another day, maybe 2 or 3 days, depending on how much water you use in your own. And if you look, you can see that this got left alone once all the water had been taken out of the salt layer. But the other really interesting part is we're starting to see these formations all along the top. So again, we start with something that is just a few different compounds and kind of looks like colored layers of mush. And we end up seeing that continue to separate and eventually leaving us with our very own pure forms of copper, which is really beautiful. And now you have seen how to use some chemistry and the power of single replacement reactions and bonding affinity to grow your own crystals. I hope you enjoyed today's demo. Again, my name is Josh. If you have any questions, comments, if you want to correct me on any of the things that I got wrong or that I misspoke about, please let me know. Let us know what else you would like to see, and especially if you'd like to see more demos like this one. And again, you can see all of our resources at our website, azscience.org. Thank you so much for joining, and I hope you have a wonderful day. See you all next time.